Okay, next, we look at how to use integrated rate equation. So previously, we already learned how to use differential rate equation, how to determine order of ration from rate law. So right now, we want to look at how to answer question regarding integrated rate equation, how to use this equation. Okay, so the decomposition of ammonia on tungstens at 11,000 degrees Celsius with the rate constant 2.5 times 10 to the power of negative 4 molar per minute, given the initial concentration of ammonia is 0.75 molar. So the first question asks you to write down rate equation. Rate equation is an equation that connects between rate constant, concentration of reactant, and order of reaction. So how to determine order of reaction? So there are four ways to determine order of reaction. If the question give you rate equation from initial rate method, so we cannot use initial rate method because there is no experimental data. So when you change concentration of reactant, so you look at effect on rate of reaction. So there is no data for that one as well. But you can determine order of reaction from unit of K. Okay, so unit of K, rate constant, is molar per minute. So molar per minute means that your K is 2.5 times 10 to the power of negative 4 molar per minute. So this unit is suitable for zero order reaction. So your reactant has zero order reaction. So rate is equal to K, concentration of NH3 to the power of 0. So your final answer is rate is equal to K. Okay, anything to the power of 0 is 1. So you need to simplify your answer. Okay, so B, what is the half-life of this reaction? So initial concentration of ammonia is 0.75 molar. So what is the time taken for this concentration to become half? So I want to know the time taken, okay, for this concentration to become half. So for zero order, formula for half-life is concentration NH3. So we don't use A anymore. So we substitute A with the correct reactant. So initial divided by 2K. So initial is 0.75 divided by 2 times 2.5 to the power of negative 4. So you will get, okay, so you will get 15,000 minute. Why is it minute? Because the unit here is minute, not second. Okay, so 15,000 minute is the time taken for the initial concentration 0.75 to become half. Half is 0.375. So from 0.75 to become 0.375 molar. So the time taken is 1,500 minute. Okay, so that is half-life. Okay. Okay, so the last example, what is the time taken? So what is the time taken when 0.475 molar of ammonia is being changed to nitrogen and hydrogen? So 0.475 molar ammonia changed to or converted to product. So nitrogen and hydrogen is actually your product. So 0.475 is actually the value of concentration of reactant converted to product. So this is the value that decompose. Okay. So if you want to find the time taken, so we know the initial concentration is 0.75 molar. So we want to find time. So when concentration of ammonia remain is 0.75 deduct with 0.475. So this is 0.475 is the value of concentration converted to product. So ini yang jadi product. So we need to find the remaining concentration. So 0.275 molar. So we want to know from 0.75 molar initial. So from 0.75 molar, 0.475 molar converted to product. So the remaining is 0.275 molar. So use integrated rate equation. So integrated rate equation is normally used for question like this. You have initial, you want to know time. So this is the remaining concentration. Okay, negative KT plus with concentration ammonia at initial. So it's equal to 0.275 negative 2.5 times 10 to the power of negative 4 plus with 0.75. So the time taken is 19,000 minutes. Okay, so ayat 0.475 molar of ammonia being changed to nitrogen and hydrogen. So maksud ini yang converted to product. Ini yang dah deform, yang dah deplete jadi produk. Ni adalah value yang jadi produk. So dekat dalam equation yang remain, NH3 yang remain. So kita kena tolakkanlah dengan initial. Okay, so the time taken is 19,000 minutes. Okay, next example. The reaction of 2 mole A becoming B has rate constant. So given rate constant K 2.8 times 10 to the power of negative 2 per second. How long will it take for A to decrease from 0.44 molar to 0.14 molar? So the time taken for the initial is this one to become this one. So 0.14 molar is remaining. Okay, so how to know you want to use zero order equation or first order equation or second order equation for the integrated rate equation? So we look at unit of K. So unit of K is suitable for first order. Okay, means that A has first order reaction. So the unit K determine the order of reaction. So we need to use integrated rate law, integrated rate equation for the first order reaction. Okay, so ln concentration A. So your reactant is A. So that's why I write down A is equal to negative KT plus with ln concentration A at initial value ln 0.14 negative 2.8 times 10 to the power of negative 2 time ln 0.88. So time is equal to 65.65 second. Because right now your rate constant is second, so time is in second. Okay, so this is the time taken for the 0.88 to become 0.14 molar. Example 3, the decomposition of SO2Cl2 is a first order reaction. Calculate the value of rate constant K at 500 Kelvin if 5% of SO2Cl2 decompose in 6.75 minutes. So this is the first order reaction. Okay, so the time given is 6.75 minutes. So the initial concentration will be 100%. Okay, so 100% waktu awal lah. Okay, selepas 6.75 minit, 5% decompose. 5% converted to product. So yang tinggal, yang remain adalah 95% lah. 100 tolakkan dengan 5. Okay, so we use integrated rate law for the first order. Okay, and then we insert all the value and then we will obtain value of K which is rate constant and then the unit will be per minute. Sebab time kat sini dalam unit minute lah. The answer is 7.6 times 10 to the power of negative 3 per minute. Okay, next question. Specify the half-life for the decomposition for this reaction. So this is a first order. So half-life for first order, the formula is ln 2 over K. So ln 2 is divided by rate constant Okay, so half-life is 9.12 minute. So from 100% to become 50%, the time taken is 9.12 minute. Katakanlah dia adalah second order reaction. Katakanlah dia ada second order reaction. So dia bagi tahu if it take 0.2 minute to decompose 15% of 0.3 molar. So this is the initial. So what is the value of K? So we cannot use 100% and then we cannot use percentage. Okay, so in the formula we cannot use percentage, 100% and 85%. We cannot use that one. We need to use the real value. Okay, so initial concentration is 0.3. So at time 0.2 minute. So the remaining is 85%. So 85% from the initial value is 0.255. So daripada 0.3 nak berkurang jadi 0.255. So masa dia adalah 0.2 minit. So untuk second order kita tak boleh guna value percentage. Kita kena guna value concentration yang betul. Sebab kalau saya guna percentage, contohnya dalam kes ni kan saya guna percentage, so jawapan saya lain. Kalau dia first order, guna percentage boleh. Kalau ada real value pun sama jawapan. Tak ada masalah. Kalau dia first order. Kalau dia second order, memang kena cari real value of the concentration.